So in this video we will deal with electric field due to infinite and semi-infinite rods, right? So electric field due to infinite rod. In previous sections we have talked about the electric field due to ring at its center, at its axis, and electric field due to arc. And then after next video we talked about the electric field due to finite rod, all the three cases: axial point, equatorial point, and any general point. So in this video we'll talk about the electric field due to infinite rod, and for that I'll be using the result used or derived in just previous lecture, that is the electric field due to a finite rod at any general point. So let me just revise it once again. If I have a rod having charge q, length L, if I have a point at distance r, that is P, and if this angle is theta 1 and this angle is theta 2, then electric field at this point P will have two components. One is this perpendicular to rod and the other one is this parallel to rod. This was kq by lr sine theta 1 plus sine theta 2, and this E parallel was kq by lr cos theta 1 minus cos theta 2. So I'll be using these results, these two parallel and perpendicular electric fields, in order to get the electric field due to this infinite wire or infinite length rod, right? So for an infinite wire it is always preferable to define charge in terms of charge per unit length. So I'm defining lambda to be the charge per unit length, that is lambda coulomb is the charge in each meter of this infinite rod or the wire, right? So at distance r, let's say if I have a point P, then at this point P the electric field will have only one component. E parallel will be 0. Why is it so? Just I'm telling you. If I'm saying that this is an infinite wire, this moves up to plus infinity and here it goes to minus infinity, then for this point P, if I want to see this angle, theta 1 will be equal to 90 degree. This angle will be 90 degree. When this wire goes up to infinity, you can see it here. Let's say this is a very long wire as compared to this distance, the point is very close. If the length of wire is very large, then I'll see that ये जो दूरी है ये बहुत कम नज़र आएगी हमें. तो यदि ये दूरी बहुत कम है और ये वायर बहुत बहुत लंबा है, तो what I'll find is ये जो एंगल है, this angle is almost tending to 90 degree, and obviously the lower angle will also be almost equal to 90 degree, है ना? ये बहुत लंबा वायर है, ये एंगल 90 डिग्री की तरफ ट्रेंड करेगा, ये एंगल भी 90 डिग्री की तरफ ट्रेंड करेगा. सो इफ आई यूज theta 1 to be 90, theta 2 to be 90, cos 90 is 0, so I will not get any parallel electric field, any parallel component of electric field. So E parallel will be 0, and simply E perpendicular will be kq by lr sin theta 1, that is sin 90, and again sin theta 2, that is again sin 90. So sin 90 plus sin 90, that is 2. So E perpendicular is simply 2k q by L r. This q by L is simply lambda, charge per unit length. So what I get here is 2k lambda by r. This is the direction of, this is the value of electric field due to a infinite wire. If the wire is positively charged, then the electric field will be in this direction and it is equal to 2k lambda by r. If the wire is having negative charge, then the electric field at this point P will be towards the wire, and it will again be equal to 2k lambda by r, right? Now if I talk about case 2, that is this infinite wire was the case 1, right? This is the case 1 for infinite rod or infinite wire. So in this case too, if I talk about semi-infinite wire or rod, सेमी इनफाइनाइट कहना अपने आप में ही बड़ी अजीब सी बात है, क्योंकि इनफाइनाइट तो इनफाइनाइट ही होता है, बट स्टिल व्हाट आई मीन बाय सेमी इनफाइनाइट इज दैट द पॉइंट P is at the corner of this wire. इस केस में I can simply say that the angle made by this line with this line will be 90 degree, and as we know that नीचे की तरफ कोई वायर है नहीं, बट यदि मैं बनाने की कोशिश करता तो जो θ2 एंगल मैं मेजर करता वो इस ओर मेजर करता θ2, बड़ी वायर तो है ही नहीं, तो ये जो θ2 है ये इनफैक्ट बिल्कुल इतना सा ही होगा, जो कि ऑलमोस्ट कितना हो गया देखिएगा आप यहाँ से, यदि मैं θ2 नाप रहा हूँ, ये वाला एंगल नाप रहा हूँ, तो ऑलमोस्ट टेंडिंग टू 0. So θ2 in this case will be 0 and θ1 in this case will be 90 degree. So if I use E parallel to be to this kq by LR cos θ1 minus cos θ2, so cos 90 minus cos 0, that is 1. मैंने कहा ही था मॉड ले लेना है, हमें इसका -1 भी आ रहा हो तब भी 1 ही काम का है. Q by L can easily be treated as lambda, so k lambda by r is the electric field which is parallel to the rod. And same way, if I talk about E perpendicular, then I'll get as kq by lr sin θ1 plus sin θ2. So sin θ1 is sin 90 degree and sin θ2 is simply sin 0 degree. So it is 0, it is 1. So what I'll get is kq by lr, k q by l. Q by l is again lambda by r, right? So what I get here is the parallel component of electric field in this case is k lambda by r. This perpendicular component is k lambda by r. This parallel component is also k lambda by r. So these two components are k lambda by r, but the resultant, that is E net, will be the vector sum of these two k lambda by r's. That will be this net electric field with x-axis or the direction perpendicular to rod will be just 45 degree. So this way we have concluded the electric field due to finite wire and semi-infinite wire. Finite wire has only one component which is perpendicular to the rod, and that was 2k lambda by r. In case of semi-infinite wire, we have two components, k lambda by r perpendicular to the rod and k lambda by r parallel to the rod. The net resultant is √2 k lambda by r. इन दोनों का रिजल्टेंट है ये √2 k lambda by r, which is at 45 degree angle. Okay.